It's so easy to create an AI agent in Kotlin. Let's see how. More and more software is being powered by AI, and agents play a crucial role in that. An AI agent is a computer program that uses a large language model as its brain to solve a given task. But what does it actually mean? Let's find out in this video. We'll start from scratch and see how to communicate with an LLM in Kotlin. We'll be using Koog, a framework developed by JetBrains. First, we'll create a new project and add the Koog dependencies we need. I prefer to use a version catalog, so let's add one. Then we specify the Kotlin and Koog versions. Koog comes as a bunch of different packages, so you can pick and choose the features you want. For our example, we'll grab Koog agents, Koog tools, and OpenAI client, plus the Kotlin serialization plugin. We also need to add this to our Gradle build file. Now we can start coding. First, we'll create an LLM client to handle the connection between our application and the chosen LLM provider. We'll use OpenAI models and need to specify our API key. You can copy it here directly, but it's better to store it in an environment variable. Next, let's choose the model we want to use. In our case, it's GPT-4.1 Mini, a cost-effective model that is sufficient for our needs. Koog abstracts the details of communication with LLMs. To switch between model providers, you simply create a different LLM client, such as an Anthropic one, and choose a different model, such as Claude Sonnet. All clients implement the LLM client interface. A single client can work with many models, so you can pick up a model for each interaction. Next, we need to create a prompt, specify its ID, and pass in arguments. One of the key ones is temperature. I would use 0.7, a good balance between creativity and consistency. Alright, let's ask the LLM to translate the user input into German. Now we connect to the LLM by sending our prompt and passing the model as an argument. Since executing an LLM request as a suspend function, we can mark the main function as suspend as well. The result is a list of responses. In our case, it's one element, so let's print out its content along with the meta information attached to it. Let's run our program and enter the input. You can develop AI agents in Kotlin. After waiting a bit, it returns the translated line and some meta information, including a timestamp and total input and output token counts. So far, so good. Exchanging text messages alone is limiting. Let's teach the LLM to interact with the real world, like sending money, by calling a tool. Now, it can't actually send money by itself. It can only return text. But we can teach it to trigger a send money action based on the user's input. If you're new to the idea, let's quickly build a tool interaction by hand. We'll have the model use JSON syntax we provide, so we can see exactly how it works. Then we'll redo it using Koog's built-in tool support. Time to code. Let's change our example and start by updating the prompt ID. We add the following system message. You're a banking assistant. You can send money by writing the following JSON. Then we provide the structure of that JSON. The name should be send money and the parameters are recipient, amount in euros, and purpose of the transaction. Next, we provide a user message, something like send 20 euros to Daniel for dinner at the restaurant. Let's run it, and sure enough, the model returns the correct JSON. We could parse it and run the function, but we won't in this video. Modern LLMs support tools out of the box, and frameworks like Koog handle the implementation details for different providers. And that's what tools are all about. A tool is any function the LLM can call based on your description. Under the hood, it uses special syntax LLMs were trained on, and the exact format varies between providers. You don't need to know the details. Koog lets you use almost any Kotlin function as a tool. Let's walk through an example of sending money step by step. User says, send 20 euros to Daniel. We send this request to the LLM along with a list of available tools. In our case, just one, send money. The LLM processes the input and returns the chosen tool name along with its arguments. That's called a tool call. From there, we can invoke the tool, calling any function in our environment. For example, show a confirmation screen, and if the user agrees, perform the transfer. I want to highlight that the large language model doesn't run the tool itself. It just picks one. We invoke it on our side. We are getting closer to the idea of an agent, a model that uses tools in a loop, based on feedback from the environment. First, let's implement the workflow with a single Send Money tool in Koog. Koog gives you a few ways to define tools, but we'll go with the easiest. Just add the tool annotation to a function. That's it. Koog now knows that this function is a tool, and it can send its signature and description to the LLM. Our Send Money function will have 3 parameters: amount, recipient, and purpose. All parameters and return types must be serializable, so Koog can send them to the model and deserialize the response. For simplicity and reliability, it might be good to stick to basic types like string or numbers. To keep this example small, we'll just ask the user for confirmation in the console. The LLM only uses the result of the tool call as input. It doesn't know or care whether the money was actually sent or how the function was implemented. Always return a descriptive result from the tool call to the LLM, even if the tool is primarily used for its side effects. Let's ask the assistant to add the LLM description annotations. Koog will send an LLM a tool function signature that includes its name, parameter types, and return type, together with function and parameter descriptions. Next, let's create an agent that can call this tool. We'll use Koog's implementation, the AI agent class. It runs prompts, manages tools, and can set up additional features. We need to pass in the Koog prompt executor, which acts as a high-level abstraction for model interaction. While LLM client is a low-level layer for communicating with different LLMs, the prompt executor builds on top of it, allowing you to add things like monitoring and logging. A single executor can manage multiple LLM clients, useful when your code interacts with different model providers. In our case, we use a single LLM prompt executor, taking the client as an argument. Since we only use the OpenAI model, we can create a simple OpenAI executor directly. It's the same code. Next, we need to pass in a tool. The agent expects a tool register, which typically contains multiple tools. The tool register is like a hub for all the tools an agent can use. It lets you register new tools and easily get them later by name or type. To create it, we call tool registry and we add a tool using the tool function. You can pass a reference to a function annotate it with tool. Let's pass the tool register to our agent and add a system prompt. You're a banking assistant, accompany the user with their request. Then we pass the user message, send 25 euros to Daniel, as an argument when we run the agent. Let's output the result. Now we can run this code. Look, our tool, the Send Money function, gets called. We see the please confirm the transaction message from the Send Money implementation. Let's say we confirm, and then the LLM sends us the final response, saying the transfer was successful. To better understand how all of this works, let's track the request and response from the LLM by adding an event handler. We could also use proper tracing and logging, of course. That's, by the way, why we see these red arrow messages. Usually you provide a logger. But to avoid overly verbose logs, I'm using this approach in the video. Let's add the event handler dependency, both to the version catalog and to the script. AI agent takes an install features lambda as its last argument. This allows you to install features like tracing, agent memory, or like in our case, an event handler. Typically, you call install and pass the feature name. But for this case, we also have a convenient extension function called handle events. We want to handle 2 types of events: before the LLM call, where we'll print out the messages and tools, and after the LLM call, where we'll print the LLM's response. Let's run our code again. We steer system and user messages, along with the Send Money tool definition, in the initial request. Then we observe that the LLM's response is indeed a tool call, and it includes all the argument values. Koog calls our tool. We see the console output and can enter the confirmation. Next, Koog sends the result of the tool call back to the LLM as the next request. Finally, the model responds with "it's done" type of message. Tools are often described as functions the LLM can use to give you the result you need. But I also want to highlight that you can provide the LLM with a tool to call for its side effects, and in some cases, the tool invocation is the result. In this example, the LLM returns a final confirmation, but the main action was actually performed during the tool call. Let's now return to the general flow of basic agent with tool calls. The user sends a prompt to the agent. The agent calls the LLM. It might resend the same prompt along with available tools, or it might add some additional context. The LLM returns a response, which could be either a text message or a tool call. If it's a tool call, the agent can invoke the tool. It gets the result from the environment, which it then sends back to the LLM. This process goes on until the LLM no longer wants to call any tools and reaches the final answer. That's how it works. Let's reiterate. A basic agent is a module that uses tools in a loop based on feedback from the environment. We say that such an agent follows a universal strategy. Simply give the LLM the task and all the available tools. The LLM kind of becomes the brain. It decides on its own which tools to call and in what order. Let's add some more tools to our example to see this in action. Usually, we want to send money to a specific user, not just an unknown Daniel. To handle that, we can give the LLM access to the user's contacts. And if the recipient is unclear, say we have 2 contacts named Daniel, we can provide another tool that asks the user to choose the correct one. So now we have 3 tools: get contacts, choose recipient, and send money. The send money tool now requires the ID of the contact, not just their name. Let's code it. Let's implement a contact class containing its name, last name, and a phone number. Then add some mockup data. Now that we have several tools, let's define them all in a money transfer tools class. This class should implement the toolset interface. The send money implementation stays almost the same. It only takes a recipient ID instead of their name. Also, let's add sender ID as another parameter. Since we have it in our mock data, let's display all the recipient contact details, their name, last name, and phone. Next, let's implement the getContacts function, which returns a list of contacts. Since LLMs work with text, we can simply send the list as a string. Next, the last tool to implement, choose the recipient. Let's ask JetBrains AI Assistant to generate LLM descriptions and then implement the function. It finds all the contacts that could match a confusing recipient name and asks the user to choose the correct one. The result is an ID of the selected contact and a descriptive message if nothing was found or selected. You often have a choice: give the model information as a tool or include it in the context, like in a system or user prompt. For example, we could list all the contacts in the prompt or create a filter contacts by name tool so we don't have to send the whole list. It's worth experimenting to see what works best for your use case. For this demo, we'll go with 3 tools. Let's now add all these tools to our agent's tool registry. We can do that in one line by calling tools and passing the money transfer tools instance. The tools function adds all the annotated methods defined in a given toolset as separate tools to a registry. It expects a toolset as a parameter, and that's why it's important for money transfer tools to implement toolset. I've again visualized what's happening for you if we run our agent. The user sends a request. The agent forwards this request along with a list of all the available tools to the LLM. The LLM first decides to get all the available contacts. The agent calls the tool. The environment returns the list of contacts. The agent then sends the tool result along with the previous conversation history, so the LLM understands the context. The model sees that there are 2 contacts named Daniel, so it decides to call the choose recipient tool. That tool requires user input. The user confirms their choice, and we send the result back to the LLM, once again including the full history. Finally, the LLM decides to call the send money tool, providing the correct recipient ID as an argument. Let's now observe that in action. Since we have our event handlers installed, we can check the requests to LLM and its responses. We see that 3 tools are sent to the model. First, it chooses to call getContacts, and we send back this information. Next, it calls choose recipient. Koog calls our tool, and we need to choose the contact. Let's say we mean Daniel Anderson. At the next step, the LLM indeed wants to send money to him. We can confirm. We always send the LLM the entire conversation history. At first, it's just the system and user messages, along with a separate list of available tools. Then the LLM decides to call a tool, and we append the result. It calls another tool, we append that result to, and then yet another. If you only send the last message, such as a tool call result, it won't remember what your original request was. The good news is, Koog handles it automatically for you. Each time when LLM decides to call a tool, Koog calls it and appends the result to the list of messages. By the way, Koog also lets you optimize the message history using different history compression approaches. But that's a topic for another video. So now you understand what an agent with a universal strategy is. A model calling tools in a loop. We give the model the tools, all the available tools. Let it decide which ones to use, call those tools to get results, and send them back to the model. That's it. You can think of it like this. The LLM is the brain. It makes all the decisions based on your input. You don't know which tools it's going to call or in what order. That's exactly what we saw in our example. The LLM had a list of tools and decided on its own which ones to use and when. It was able to take the result of one of the tool calls, like the recipient ID, and use it as input for the next one. You can ask a model to solve a pretty complicated task, and only provide a list of tools, using a basic universal agent we just discussed. It works surprisingly well. Try it yourself. It's all you need to start creating your own agents. I really want to encourage you to try that. Define tools, pick up the model, ask it to complete your task with the provided tools. For a prototype, it's more than enough. You can see what LLMs are capable of and what their constraints are for your specific use case. However, such a universal strategy of providing a high-level task and all the available tools no longer works when the complexity grows, when you start to productize your functionality. Especially if you have a lot of tools, you often end up using different models and different sets of tools for different subtasks. Koog lets you orchestrate how those subtasks are connected to each other. Think of it from the perspective of how much autonomy you want to give LLMs. There is no universal answer. It depends on your use case. As a developer, you figure out which tasks the LLM can handle on its own and which need to be broken down and coded explicitly. The ability to move this LLM autonomy slider and to find that sweet spot for your requirements is crucial for real-life production scenarios. And Koog gives you this flexibility. It does so much more. Memory, persistence, history compression, advanced agent strategies, tracing, observability, everything you need to run agents in production. You'll find links to more Koog resources below. Thanks for watching. You are now ready to start building your first Kotlin agent. Let's go.